Either borrow view, I don't know what that is. And this one, I think it's. Yeah,
I'm just gonna talk. All right. And well, this is entertaining for this one. Yeah, go ahead and take that one. We'll see if we can get the camera over there.
This one or this, I guess,
Here. Okay.
camera can.
Yeah, and I don't actually see a camera control for this one. That could be another. Slight technical delay, but I think we got it under control. So welcome to the Northwest C++ Users Group April meeting. First off, we'd like to thank Microsoft for sponsoring our reactor room and our Microsoft Teams support, and also our technical support when we've got problems with the monitors and video in the room. We do have a code of conduct. We follow Microsoft's code of conduct, so pretty straightforward. Just, be nice to everybody. And announcements. So in July, we're going to be doing a joint meeting with the Rust group. For those folks online, the Rust group actually meets basically at the same time we do every month. And they're just out in another room out there. So in July, what we're going to do is we're going to have a joint meeting between the two groups, and we're going to do a language panel. We've got a pretty good group of speakers to, Mojo, Hilo, C++, Rust, Swift, a couple more in there I'm missing. Anyway,
and we're doing C.
We decided not to do C.
Oh, okay.
If anybody knows Go and would like to present on Go, get in touch with me and I'll get you a little template. You don't really have to know it in depth, right? This is going to be a very surface level kind of, here's what the language is about. And we've got a slide deck that, makes it all pretty easy.
What about VBA?
No. We're also not doing AGOL PL1 or B. Okay, August is going to be lightning round. So if you have a presentation that you would like.
I'm not hearing yes.
Oh, folks online, can you hear somebody?
Yes, I can hear.
Oh, okay.
Okay.
Photos?
Cool, thanks. Look, you get video or you get microphone, not both.
It's
I can hear
Deloitte
okay.
Okay, thank you.
Deloitte uncertainty principle.
Yes, you could hear me or you can see me, but you cannot hear me and see me at the same time. Okay, anyway, the August meeting will be lightning rounds. These will, 5 to 10 minutes or more, depending on how many people decide to show up with a presentation or not. But if you got a short presentation or a short topic you would like to do, start thinking about August. September and on is still open. So, probably about May or June, I'm going to really start begging for speakers for September, October, and November. So if you've got a bigger talk you would like to do, let me know, please. After this meeting, a bunch of us tend to get together at the local Red Robin. Folks online are invited, of course, but it may be a bit of a commute. It's actually fairly close here, so just pop over to 148th and you go up to the Red Robin. And everyone's welcome to join. I'm also now hearing the folks from the Rust group are showing up there too, so.
No, they're going to Redmond Town Center's Red Robin.
Oh, they do Redmond Town Center's Red Robin.
Right.
Oh, okay.
They didn't want to have like dueling user groups fighting it out about which language was better.
I didn't catch that. I just caught Red Robin, so, okay. Never mind, it will just be us and you do not have to defend against Rust. Okay, please keep your questions short and focused so everyone gets time to interact with the speaker. Please do not interrupt the speaker or other members when speaking. And with that, I'm going to turn it over to Dan, who is the speaker for tonight.
Unfortunately, I can't open PowerPoint document. So I guess I'll have to reboot.
Okay.
I know I'm supposed to say nice things about Microsoft here. Don't get me started about Windows.
That's okay for folks who didn't notice I'm actually running Linux.
It's amazing that we didn't notice that it was able to connect to broadcast, work with Microsoft.
That's pretty good.
Yeah, it actually, they've gone a long way with this particular OS. So if anybody cares while we're waiting for the reboot, it's actually Pop OS that System 76 makes that I'm running. So, and it's also on their hardware. So that gives it a little bit of an advantage. Okay. I can see the technical fun's just going to continue with us for the evening. We'll roll with it. I guess the other thing we could do is I could try to connect. You could try to send me your slides and I could try to show them from mine if that.
This is unreal. It says now it's saying something about safe mode. Oh, here we go. Oh, I got it.
Okay. You started to panic me there for a minute. Safe mode is not something you want to see unless you hit a button.
Windows has been out for over 30 years. Okay, start.
I think.
Okay, so need a
Oh, yep.
one Lloyd, pass that turn. Save that for June.
There it goes. Good.
So,
It takes a second to.
okay, all right. Doing that, I'll go into.
You might have to tell it. Normally it would do it by now.
Worked at home.
Do a right click in display properties and see if it's recognized. If not, check and see if I.
Windows key P might also help.
See if I can read this just in case.
This is weird. It's giving me the usual display.
Okay, and of course the USB drive I've got does not want to go.
It's still Linux.
Huh?
It is still Linux.
Yeah, and this was formatted under Windows.
I really need to move to Linux. This is just stupid.
Well, Dan, see if you can read that. That's a thumb drive. See if you can get your presentation on there. While you're doing that,
Does anybody,
I will do the unmentionable and turn this into a Windows machine.
does, where did the old display settings go? Display. Oh, here we go. Multiple displays. Here it is. Okay.
You get it?
We didn't find another display.
Okay, it's not recognizing.
I'm at Microsoft and it doesn't This is the only. And this was working with yours?
That is working with mine, but let's see if we got another display for it on there somewhere. Micro SD.
Got these here.
Yes, that will work. Okay, let me see.
With the same, but it's the same cable.
Yep, put that cable in there and plug in there and see if it'll pick that up. It's not picking yours up. See if you can get your presentation onto the thumb drive and then I can just put it on mine. Or you can give me your. So go ahead and give me the cable and let me see if I recognize on mine. Which would be really hilarious if it would recognize Linux and not Windows.
USB port. Wait.
Okay. So I can display if we can get the presentation to me.
This goes into a USB.
Yep.
You did hear the guy who invented the USB died?
Oh, no, I didn't.
Yeah, at his funeral, they lowered his coffin down and then they had to raise it back up, turn it around.
Yeah, just throw that on the USB stick and I'll be able to present it.
I don't see the drive.
You don't see the drive?
Should be right there.
I say, that's my little trusty USB stick that goes everywhere. And it's small, which is why I carry it. Buy them anymore because, well, it's decades old.
Really, this looks like something new because it's thin and
It's
light.
really old. That's entertaining. Ah.
It's you.
All
see
right.
it.
Okay.
We're live.
Sorry about this. Works fine at home when I hook it up to another monitor.
All right, we got control. Go for it, Dan.
You pass me the PC?
Oh, you want to do, okay, I'll just tell me when you want to change.
Well, no, I need to, because,
Oh, you need to see the slides.
yeah,
Okay.
and I need to present a view.
Oh, now, okay, you're in LibreOffice at this point, so that may be a little different.
I don't have my notes.
Yeah, let's see. Okay, let me see if I can fix that.
That's going on. I'll go with this.
You could read
While
that's
we're
a
waiting,
ruling.
can you tell us what digital blasphemy is about?
Oh, so digital blasphemy is it's basically a guy who does wallpapers for Windows. That's his kind of whole business. He's been doing it for 20+ years and I like his artwork, so I got a subscription. I use it on all my backdrops.
That's cool.
Dan, you could bring up the speaker notes on your PC and then just have Lloyd like advance the.
Yeah, would that work?
Oh, wow. That's a big idea. That's pretty.
Does it do animations?
Don't know. Let me see if I can. Display settings. Let's see. Multiple displays.
Well, yeah, I mean, it works, that part works.
Duplicate, extend. Okay. Changes. Now, if I do F5.
There we go.
And you got speaker notes.
Okay, great. Except that it's
Oh, so what you'll,
no control here.
hang on. So just use the arrows up and down. So just these two.
Okay, it's not, it's,
Yeah, I know it's gonna be awkward using somebody else's setup.
okay.
Okay.
All right, well. Hopefully this was reasonably worth waiting for. All right, well. A lot of stuff, man. Okay, so this back to basics talk about the three-way comparison operator, also more affectionately known as the spaceship operator. So I wasn't sure if a feature in C++20 was, would be a valid back to basics topic. But then it has been about 5 years, so I guess it counts, right? Okay, so C++20 brought us this new operator. And sorry. Well, the problem is that the notes that I'm seeing now are actually for the next slide.
Oh,
Okay, I'm gonna wing this. Let's see what happens. Okay, so not too long ago, if you wanted to implement comparative operators, you had to list them all out. You had to declare them all and implement. What you could do is, if you had the equality operator and less than implemented, you could implement the remaining 4 in terms of those 2. But still, you had to list them all out, which was, rather inefficient. These can now be replaced with a single operator, the spaceship operator, which you see here. I have the little dagger mark there. There's another option, but for now, just hold tight and I will get to that. But yes, you can replace all of these with the single spaceship operator. Okay, so also with the with C++20, if you define the equality operator, it now automatically implies the not equal operator. So if you define equality, you get the non-equality operator for free, which is quite convenient. Now, back to my dagger remark. There actually might be cases where you want a separate equality operator defined, and then you can use it within the context of the spaceship operator in its implementation. We'll see an example coming up. Okay, so why is it called the spaceship operator? Well, because it kind of looks like a flying saucer. So to prove this point, well, remember those of us who are old enough to know, or those of us, others might have seen it in reruns. Yeah, what a great series. There's also Zactu and Mondo from Way, Way Beyond. I don't know if anybody remembers that one. It's a hilarious Saturday Night special, or Saturday Night Live special skit. Of course, there was The Day the Earth Stood Still. And this one I didn't know about until recently when I was watching MeTV. Did you know the Joker in the original Batman series built a flying saucer to fly to Mars? Yeah.
There's an almost obligatory joke, but I'm not going to make it.
Wait until Red Robin. So, what you might not know, according to some rumors that came out of the ISO committee, there were some other proposals, but they were not accepted. One was to write it this way, and it was proposed as the 737 operator. Another one was to have the angle brackets in the same direction. That was the command and service module operator. Another one, gets a little wilder, was this. Anyone want to take a guess as to what that is? The duck just came down from the ceiling. Ace winner, yes. That's impressive. Yeah. The Discovery 1 operator from 2000 Space Odyssey.
Good luck getting all the equals.
Yeah.
For those.
Yeah, remembering the number. Yeah, and then there's one more. Anyone want to take a guess at this one? The Starship operator. Okay, so what I've found, at least my experience, is a lot of the textbooks and reference books and online references. This is the kind of example they give you. So it's usually like a point class with 2 or 3 dimensions. And I've added a stream operator so we can see what we're doing. And they just define the spaceship operator as the default. Okay, well, what does this do for us? We get a lexicographical comparison. So if we have 3 points, as you see there, 106, 874, and 419, if we look at the equivalence operator, then, as you probably know, the data members have to match up exactly. And so the first one is obviously false because none of them match. And the second one is true because it's not equal, so they don't match. Third one, identity, trivially, it's true. But where it gets maybe more interesting is for the inequalities. So the way it works is it takes the first data member and compares those. So 8 is greater than 1, so therefore the right-hand side is greater. That's true. And similarly, going the other way, 8 is greater than 4, so that's true. You might have a tie. So in this case, the x-coordinate are the same value. So what it does is it moves to the y coordinate and it sees that 2 is greater than 1, and that's true. And that's usually the end of the textbook example, and then they move on to something else like unique pointers. So you're kind of sitting there, okay. So maybe something a little more illustrative, we'll look at a fraction class. And so we'll assume for simplicity that the numerator and denominator are non-negative integers. That way it makes the inequality test a little easier. You don't have to mess with switching around with negative numbers involved. Of course, the denominator will never be 0, and we'll assume that the fraction is simplified at construction. So if you were to do this the old way, and also, by the way, as you probably see, I'm using modules here. I really like modules. We should become more mainstream. But anyway, again, this is the old way. You would have to declare and define all 6 comparative operators. Okay, so let's see what we can do with the spaceship operator. Okay, so what we'll first do is, oh, I'm sorry, it's a slide ahead. Okay, what we'll do first is we'll proceed naively using the textbook example, using the default for the spaceship operator. And again, scratch that. Okay, so what happens? We define fraction 1 is 1/2, fraction 2 is 1/5. What happens when we compare them? Well, that's obviously wrong, right? Because again, the numerators are a tie. We move on to the denominator. It thinks, okay, 5 is greater than 2, therefore 1/5 is greater than 1/2. So that's not going to work for us. So what I'm going to do here is I'm going to replace the 6 comparison operators with 2. What I'm going to do in this case, again, the remark that I made earlier, is I'm going to define the equality operator as the default. And so this, again, is just numerators match, denominators match, it's equal, otherwise not equal. So that default's fine. Then for our spaceship operator, it looks something like this. And you may notice it returns a strong ordering type. I want to hold that in abeyance for now. I'll come back to that. But what's more important at the moment is, I'm sorry, the body, because I guess.
It's running in LibreOffice. It may tweak the slide.
So yeah, that's supposed to go over less. But anyway, so in the first case, we do cross multiplication, and the active object, which is on the left, that the product on the left is less, so therefore the active object is less than the right-hand side object. So it returns the value less, which is scoped by strong ordering. But again, the main point is it's the value it returns is less. For equivalence, here we can just call the equality operator, which we've already defined as the default, and it will return equivalent in this case. So sometimes it's convenient to do this. You might want to have a equality operator anyway. So you just stick it into the spaceship operator implementation. And finally, just to point that out. And then finally, if neither one of those is true, then the only other possibility is the left-hand side is greater than the right-hand side. So in this case, the active object is greater than the right-hand side input object. All right, so now let's repeat the same check. So 1/2 and 1/5, we compare them. We get the right result. And so now we're cooking with dilithium crystals. Hey. All right, so looking at the less, greater, and equivalent returned values in a little more detail here. What I've done here is I'm assigning to or storing the result of that comparison X spaceship Y in the variable called comp for compare. And so again, the possible return values are greater, that means X is greater than Y. Well, and assume X and Y are fraction objects again. Less than. So these get stored in the variable comp or equivalent. Okay, now about the types themselves. Oh, I'm sorry, again, I saw the next slide. This can be illustrated in this example. So I just have a lambda here that will take in a fraction, two fractions, and then the variable comp. And then the point here is it will recognize the value of comp. So you can see if it's less, it'll print out the first line, and similarly for greater. And in this case, I made equivalent, the default. So we input that there. And so in the first case, strong ordering, we get the greater result, which means the left-hand side is greater than the right-hand side. Also, just to note here, you can recognize the type, which is strong ordering. So I use type ID there. If I switch them around, then I get that I get less, meaning that frac 2 is less than frac 1. So again, left to right. And the reason I hope I'm not gilding the lily here, but the reason I bring this up is it does get a little confusing. You just have this return value, and then you got to say, well, wait a minute, which way does it go here? And that's what it means. It's going to go from left to right. And then finally, equivalent, if I define a new frac object of 1/2 and trivially compare them, they're equivalent. In fact, when I was writing this and going through the presentation and writing the sample code for this, there were times I said, like, wait a minute, what's going on here? So it does take a little bit of getting used to. Okay, now for the actual types that are returned. So first is strong ordering, what we've talked about so far. So the use case here is exact comparisons, such as with integer types. So there's no rounding error, no NANs to deal with. So strong ordering, everything is comparable, nice, and life is good. The return values, as you saw, include greater, less, and equivalent. And exactly one of these comparisons must be true. Okay, but what about for floating point types? For that, partial ordering is a typical use case. So the return values also include greater, less, and equivalent. But a floating type can have rounding error or hold non-comparable assignments, such as infinity and NAN. Although there is some comparison with infinity, negative infinity, but still it's something you have to deal with.
Can you also compare NAN to NAN, or is that not equivalent?
As you can see in the last line there, if both variables are NAN, it returns a unordered.
Okay.
To do if one of the variables has the value, not a number. The reason being that if you have two variables, floating point, and one of them has the value, not a number, test, is it greater than, the answer is false. Is it less than, the answer is also false. Therefore, they're not opposites.
I haven't tried it because with partial ordering, it does say that one of those three comparison operators must be true. So that's a good question. To try that. Okay. We go back to the drawing board later. And then there's weak ordering. So here it is possible that all three could be false. So, I'm not sure. My understanding is partial ordering is suitable for floating point arithmetic. But good question. I'll have to look into that. I've read that it can be used for things like comparing case instance strings. I'm not all that familiar with weak ordering. I didn't really get into it that much. Just coincidentally, it's kind of like weak pointers, which I've never used and don't know a whole lot about. So there's something about that being weak. Makes me weak. Anyway, so I'll just mention it here for completeness. One thing to note here, though, is the default return type for stood string comparisons is strong ordering. And in those cases, actually, the comparison is case sensitive. So I think it's lowercase is greater than uppercase. I've got an example.
Yeah, that would be right, because that's the ascending order.
Yeah. And so to show this, let's look at an int case, a double case, and a string case. String, it's not a string base. A Rickenbacker is an electric base, but anyway. So you can see that on the right, the uppercase base is all in upper caps or uppercase. So again, as I said, this takes a little bit of getting used to. You can store the result, so whatever that value is, greater, less, or equivalent, and then store it in another variable, or you can return it from a function. And so I've just stored those results in those variables that you see there. And then if I print out the results, that's what I get. So int compare is equal to, well, it holds a stood strong ordering type. And as you can see for double, again, partial ordering supposedly goes with doubles and floats and so forth. The default is partial ordering. And for a string, the return type is strong ordering again. Okay, everything cool? I'm still awake. Just to confuse things, there's also an equal return value. And for strong ordering, it's identical to strong ordering equivalent. It means that two values have exactly the same bitwise representation. And it's perfectly valid for integer values, again, such as in our fraction class, because we don't have to deal with anything weird like rounding error or NANs and that sort of thing. It is also a value that can be returned in a partial ordering type. And again, it means that the two values have exactly the same bitwise representation. And to me, it gets a little bit ambiguous here, but I'll explain what I know. It does become meaningless in the English sense of the word or the mathematical sense of the word, because if you have round off errors, NANs and so forth. It's also identical to partial ordering equivalent. So you kind of ask, well, why do we have these two different values when they do the same thing? What I've read is it indicates the intent. So you never want to compare floating types for exact equality. But you can define them to be equivalent within some given tolerance, which we'll see shortly. So you take the absolute value of the difference. If it's less than some epsilon, then you return equivalent. But you'd have to implement that yourself. This, my own preference, I would just use equivalent all the time, even with strong ordering, to avoid any confusion. Okay, so now we'll look at something where we'll use partial ordering. And this is where we're dealing with what are called limit orders for buying or selling shares of a stock. What it is, it's an order to buy or sell a desired number of shares at some specified limit price or better. So that's in contrast to a market order where you say, I want to buy now at whatever the market price is. If there's a lot of volatility or the market for that stock isn't very liquid, you can get swings in between the time you place the order and the time it's executed. Or you might, you might think a stock's too expensive and you might say, well, I'm going to wait till it goes down until the next round of tariffs is announced and buy in low. So if a stock is, say, trading 120 and you say, well, I think it's too expensive, but if it goes down to 105, then I'll buy. So you put in a limit order and say, I'll buy 100 shares at 105 a share. Okay. So in other words, this ensures that the execution will not be at a price worse than the pre-specified price. Again, you don't have to worry about volatility or the market going against you. Or again, if you think its stock is too expensive to buy or too cheap to sell, you can set that limit at the price you are willing to accept for the transaction. So buy order will not be executed above the limit price. The sell order will not be executed below the limit price. Limit orders are placed in what's called an order book on an exchange. And to see this, here's a diagram which it's an example. It's a simplified example, but what you can see here is, I don't have my pointer, but to the left, you see those are buy orders. So what it's saying is those traders are willing to buy at $20.03 a share up to $20.07 a share. And on the right, though, in blue, those are the orders to sell. So again, somebody might say, oh, I'm willing to sell at 2013. Another one says 2009. If you were to place a market order to buy, it would be executed at 2009 because that is the best offer price available in the market. But this can shift. I mean, this will shift during the day. I mean, there's a lot of movement. Orders come in, go out, but likewise for an order to sell, market order, it would be executed at 2007. Also, in reality, you would find prices going a lot farther to the left and a lot farther to the right. You have 18, 15, and so forth on down, and 22, 25, 30, and so forth to the right. So where our friend, the spaceship operator, will come in is that orders are queued by priority. So where they go in in the limit, or in the order book. So if we look at our diagram again, given two limit orders, say A and B, and we assume that they are of like type, so we're only going to be comparing buy orders together or sell orders together. We're not going to compare buy and sell. So, okay. So an order to buy A will have priority over B if first we check if the limit price of A is greater than that or B. So you see that that's going to go from left to right. So as the limit for a buy order, as the limit price gets higher, that order will have higher priority in the trading book. In the case that two trades have the same limit price, then you might look at whether they're round lots or not. So round lots, meaning multiples of 100 shares, those will have priority over non-round lots. And if that's a tie, then you might, and you can see the examples on the right there. If those two conditions are the same, then you might break the tie with the timestamp. And so if the order A has an earlier timestamp, it has priority. Now, for simplicity, or to, just keep this concise, this is a simplified approach. There are a lot more things that go into this. And the people who do this, a lot of it is in strict secrecy. So this is just kind of a simplified view of what goes on. But these second two conditions will be priorities in the vertical direction. So you have the same limit price, but one's a round lot, the other one's not, then the round lot is going to go in before the non-round lot. On the sell side, it's the second two conditions are the same. It's just the first that instead of the higher limit price, it'll be the lower limit price will have the priority. And again, this is where it can kind of mess you up because that is a lower number, but it will have higher priority. So do this one more time. So instead of the inequalities meaning less than or greater than in a numerical sense, we will take them to indicate priority. So again, a sell order with a lower limit price will be higher in priority. So for our definition, it will be greater than the trade with the higher limit price. So B less than A means that A has priority in the order book over B. Okay, so let's look at a limit order class. So we'll write a module called limit order. And before we write the class, let's define an enum class buy or sell, which just indicates whether the trade is to buy or sell. For our private data members, we'll have buy or sell. That's our scoped enum. The price at which the trader is willing to buy, so that the bid price, or sell, which would be the offer price, and the number of shares. For the timestamp, we'll just use a simple stood chrono time point. Again, these things can be more elaborate, but for our purposes, we'll just use time point, which means the number of nanoseconds since the Unix epoch, which is January 1st, 1970. those units are implementation dependent, but with the standard libraries that ship with the big three compilers, the default is nanoseconds. We'll also define a static epsilon value, which will also be constant. So it'll be the same for any instance. And I'm using the boost convention there for epsilon. So it's the square root of the numeric limits epsilon function. And finally, okay. Finally is a static trade ID. And so that will be incremented with each instance of a limit order. Again, these can be more elaborate, but we'll just count them 0 or 1, 2, 3, 4. Okay, so at construction, just take in the input values and use them to remember Admiral Stockwell in the 1992 vice presidential debates. You don't, but it's kind of a standard show. That's what who am I? Why am I here? Ask Siri. Sorry, I show my age here. Anyway, we just, this obvious, we just take in the input values and use them to initialize our member data. And again, we're going to constrain this for obvious reasons. We're not going to trade in negative shares or no shares, and it's got to have some positive price. Might be getting lower and lower, but it's still positive. We got that going for us. And then we'll also increment the trade ID. Okay, so lovely.
Yep.
Okay. This was really kind of the crux of, I mean, kind of an important point here.
You can kind of make it out.
Yeah. This is step one. This is we're going to compare the bid or offer price on the limit order. First, we're going to assert if they're not of the same type. If they're not both buy or both sell, then we'll just assert. If not, then in the, let's see, what did I do here? So you can see I've created a comp price variable of partial ordering type. And so let's see. And if it's a buy, then we're going to compare the active object price with the incoming right-hand price. And if this price is lower, then it will have lower priority. So we'll return less. And we can switch them around and it will go the other way. But again, this is one of these things where you're working with this and you write it and you think it's right. And then it's like, oh, wait a minute. So working with this operator can first work with it can might make your head spin a little bit. Okay, so if we've established that, okay, the prices are different and we have an inequality somewhere, still because we're working with a double precision variable, we want to check if it's equivalent or not. And for that, we compare with epsilon. If they are indeed not equivalent, then we'll return the result, which is in that comp price variable. So that will return less or greater. Otherwise, we'll just drop down to the next condition, which hopefully, well, these boxes really help too, don't they?
Yeah, that's Libra's probably having fun with that.
Okay, this looks a little better. Okay, for step 2, this is, we're going to check if they're round lots or not. So we define 2 Boolean variables and check if they're round lots by taking the modulus with 100. And if there's no remainder, then it's round lot. Okay, so then we compare, is one a round lot and the other not? Well, if the active object is a round lot, then we get greater. Otherwise, it's less in priority and we return that. But if they're the same, we drop down to the third condition. Okay, so that's what's going on there. And then it's only in the case where one is round, the other one's not, that we return a result. Otherwise, we'll drop down to the time step. Okay, and finally here, we're going to check the value of the time step. So again, this is one of those things. Note that the active object is on the left. If it's less, then we return greater because it's greater in priority, but it has a smaller or earlier timestamp, which is numerically less. Otherwise, it goes the other way. We return that. So as I mentioned here, this is another case where a lower value implies an object is greater. In this example, we're kind of assuming this is almost surely not to occur, but because it's just a simple example, if it happens, and we return equivalent. Okay. So, Yeah.
Would it have been the same to just do the spaceship operator between the 2 timestamps and return that, or would that have been different in some way?
those are stood chrono time, called
time point.
time points.
So they don't have a space.
So I don't know. That's a good question. It might be defined. I'm not sure.
And if it is defined, do you think it's safe to assume it does what you would expect, or maybe it's
One would think, but you might want to
for sure?
conservative side there.
For sure.
Dan, speaking of time point, we have about 30 minutes left.
Oh,
You're good? Okay.
summary.
Oh, well, that I.
You were afraid I was going to go another 30 minutes.
No, I was just noting that we lost almost a half an hour getting into some details. I just thought at the half hour point I'd say something, but.
How much more of this do we have to take?
No, this is awesome. Thank you.
Anyway, so yeah, just some references I used for this talk. First is the book by Nico Yosudis. Oh, wait a minute. Oh. Again, the next slide came up. Summary. So the spaceship operator allows us to incorporate all 6 comparison operators into a single operator implementation. Although you might want to define a separate equivalence operator and then use that inside your spaceship operator implementation. So as noted, and again, if you define the equality operator, then you get the non-equality operator for free. So you don't have to define it separately anymore. And as we saw, there's also a default option for the equality operator. So just check data member by data member. And as we saw, a default option is also available for the spaceship operator, which again is just a lexicographic comparison of data members on two objects. And as we saw, will not always suffice, but unfortunately, in a lot of resources, you find that they just do that and then move on. And so I hope what I've provided here gives you a bit more information than what you might be finding out there. Okay, now references. The book by Nico Yusus, C++20, is a really good book and devotes all of chapter 1 to the spaceship operator. So you can always count on Nico. And a little shameless plug again, chapter 2 of my epic bestseller. I do cover the spaceship operator in there, and I use the fraction example in there. But technically, I did use it for reference, so I don't want to be, like get sued by the publisher for What happened to, why can't I think of his name? The guitarist for Creedence Clearwater Revival?
Oh, John Fogerty.
John Fogerty, yeah. He got sued because he recorded a song, new song that he recorded with his previous label, and they sued him for it. So, but you got to wonder. I mean, 12-bar blues. I mean, how?
There's some weird stuff in business too, where like if you own a business and you're a single person, you
Yeah.
have to sign it once as the business owner and once as the individual. I've run into that multiple
Really?
times.
Wow.
It's like, the hilarious thing is you don't necessarily have to send it or file it anywhere, but you have to keep it on record. So if you ever forget what you agree to yourself with, you don't sue yourself. It's totally a degenerate case, but it's hysterical.
Yeah, it is. Of course, as we get older, we might need that.
Yeah.
Like, did I? Okay. And then finally, of course, cppreference.com. That's always a really good source. Okay, so I think most of you know me, but you can reach me there at cppcon.org. I will still be the student program coordinator for the conference this year. Hope you all can make it. Submit a talk, they'll cover your expenses. And I'm also on LinkedIn. So thank you very much. Live long and prosper. So if you have any questions, I can take them.
I have a question. Is there any advantage to defining the equality operator other than setting it to default? Like what would be an example of doing it?
I can't think of any offhand right now.
Maybe if you had like
It might,
a cache inside of your object that didn't want to participate in the default equality, like in your meaningful equality.
Yeah, the other one I could think is where you have equality that somehow doesn't map to the way you would think it would, like say in Unum class where, a couple things could map to each other per se in equality.
Yeah, that's true.
Or
What
also,
would be the advantage of doing that outside of the spaceship operator? Isn't the spaceship going to do the same thing for you?
yeah, you could
you could do it that way.
Yeah. Yeah, that's right. It's just, you might, in what I did, I have to go back when I was playing around with that. Actually, first, I can't remember, but I was not able to get a version of it where I defined it inside the spaceship operator. Maybe what I was doing was wrong. But I figured, well, with a class like that, you probably want an equality operator anyway. So
Probably makes it a little more clear,
Yeah.
if nothing else.
I suppose also, oh, yeah, but you're saying it's whether to define it outside rather than.
Yeah, it just seems like if you're having a spaceship, why
Yeah,
create
true.
another operator?
Yeah. And I guess it's, if you just want equality, then it's less you have to go through to get there. Anything else?
Yeah, this is a sort of a nitpick, but I noticed that you were stressing how to define this spaceship operator, but less about how to use it once it's already defined. I assume that once you define the spaceship operator, it will, in the code that uses it, all the ordinary ordering operators will take their values from the spaceship operator, correct?
Yes. Yes.
Okay.
And I do have sample code, but unfortunately I can't display it. But I will put that out on,
Yeah, just send it to me and I'll put it.
it'll go out on the website.
Yeah, if you got
Okay.
code or a repository or anything,
Yeah.
send it to me and I'll post it as well.
Okay. Do you want, I mean, should I just give you the link to mine or?
That's fine.
Yeah.
Well, let's put it this way. If it's somewhere where it's gonna stay permanent, just send me a link.
Okay.
If it's somewhere where it's not gonna remain permanent, send me the thing and I'll put it in our,
Okay. It should remain permanent.
yeah, just send me a link. It's good enough.
This is another nitpick that when you define an example of how to define the spaceship operator for the fraction type, you used in a clearly a mathematically correct way to define that. But when those operators overflow, you'll get nonsensical results. When you multiply the denominator on one side by the numerator on the other side, there's no how that you'll get an unexpected result if the result overflows in those multiplication operators.
Okay, well.
Because it'll wrap around if they're integers.
Well, I figured that, I mean, again, it's just a simple example.
Yeah.
I
said it was a nitpick.
Yeah. So, we're not gonna have, too many edge cases with it, so.
I live on edge cases.
Yeah.
and die on edge cases.
Well, I can, in your field, I could imagine that.
I do numeric stuff all the time, and edge cases are the crux.
Yeah.
Mhm.
Yeah.
That's all.
I had one question. It was more about the finance and about the C++.
Okay.
Why is the price a float? I would have expected a price to be like dollars and cents or like a integral number of pennies. Are things actually sold in the market at fractional?
I don't know for sure. I just use doubles because, decimal points. I mean, there's decimal. And also I could show an example using unordered.
Yeah.
There was that. I did think about that. Also, technically, there may be some exchanges out there that, might have like 6 7/8, something like that.
I'll go one down. So I was looking at GNU Cache, which is it's like Quicken, right? It's an open source Quicken, so you can go look at the source code. They don't actually use floats. Everything's done as integers, it's rational numbers. And specifically because you don't get off errors and things like that. So I suspect, I don't know for sure because I haven't seen like inside of an exchange, but it wouldn't surprise me if they're really doing something like that.
Yeah, might be.
There was a Cuckoo's Nest or Cuckoo's Egg. I cannot remember the exact name of the book. It's a very old book, but it was one of the first hacks that came out that was kind of like a virus. And basically what the guy did was he got into a banking system and he accumulated all the round off errors and stuck that into a separate account. And it was a considerable amount of money. Yeah, millions of dollars in several months, right? Type of thing. I don't remember the exact details, but it counts. Don't get any ideas.
What didn't I think about?
Somebody already came up with that one.
I didn't try to be Nick Leeson or Mrs. Clinton.
Yeah, I was gonna say, if we catch you in the next movie, the sequel to Catch Me If You Can.
You have like a total order, right? Got the equals operator and the less than operator. You can infer, generate the other four.
Mhm.
Yeah.
So given equals, you can infer not equals. Is it an error to define not equals in addition to equals, or can you provide the definition for not equals in addition to equals?
I'm assuming you still can because it's the language would be backwards compatible in that regard, I believe.
Yeah, I'm just trying to think. If you did so and you got it wrong, you've introduced a very interesting logical inconsistency.
Debugging or something, you might want to stick something extra in.
Yeah.
I mean, I suppose you could because it hasn't been deprecated as far as I know.
And then you mentioned like avoiding it if you have not a number or rounding. Can you give an instance where rounding would make it affect the results, or?
Yeah, like 1.0611 and 1.0612.
Mhm.
I mean, that's essentially $1.06. So they're not equal, but they'd be equivalent. I used a very, very small tolerance for the example, but
Have you ever,
when you're comparing two floating types, you don't compare things.
yeah, never compare floating types as direct equivalents. Basically, I don't know if are you familiar with how floating point numbers are represented internally?
Yeah.
Okay, yeah, basically, if you're not a even power of 2 at some point, or your calculation doesn't end up being power of 2, life gets bad.
Assuming your floats are the standard
Assuming a standard float.
IEEE,
Yeah.
whatever the.
Yeah,
thing
IEEE
is.
7, whatever.
Refer to my C++ my presentation to this body about 5 or 6 years ago.
Yep.
I covered that in detail.
The epsilon test is you lose transitivity, so A is equal to B is equal to C. Does A equal C?
Right.
And
Not necessarily.
A may equal B may. equal
Most of the
C, but
time,
A no
yes.
longer equals,
Right.
could no longer equal C as it goes beyond your epsilon. And
Yeah.
I've been worked with a program where we're trying to do things that would bite us. And
Oh, really?
we're like, oh, there's a great idea to do epsilon because these things are so close, you should treat them identically. But then you end up getting bitten by the loss of transitivity issue.
Yes. When I've done stuff like that, what we've typically done was we've said, we're going to do this many significant digits or this many decimal points and see to it that that is significantly less than the representation. So like, I can't think of, like a double, for instance, goes out to 12 or 14 digits or something. Somebody check me on that. But it's like, okay, we're going to count 6 digits. That's it. Right. After that, we're going to round or truncate. That actually solves a lot of the problems. The other thing you run into is even if you do, I don't know, Bob, if you've gotten into this or not. I get into it because I end up doing stuff between desktop and embedded systems where the floating point units are not identical. When you move code from one of those environments to the other, a typical desktop processor, a double is 64-bit, right? So float 64. They typically represent in, I think it's even up to 128 bits now internally for the calculation. When you go to an embedded microcontroller that has a floating point unit, they typically only go to 80 bits. And so if you're doing iterative calculations or something, it'll work great on the desktop because you've got that, just what I was talking about before, you've got that extra margin there to carry the error. And then you go to an 80-bit processor and it doesn't overflow, but the error creeps into that, 80th or 79th bit and it shows up. So it's, working with floating point is there's an art to it and there's a science to it. And it gets nasty. The key is just always use a representation that's significantly larger than the accuracy you really need. And then you can kind of wave your hands and it goes away. I don't know if you've had the same experience, Bob. Are you able to wave your hands that way or?
You can never wave your hands. You have to know it.
I expect you work with stuff that's even higher precision than I have at times, so.
No, actually, I work with relatively low precision numbers most of the time, but
Oh, okay.
you still can't wave your hands and ignore it. You have to know what's going on. No, most of my calculations are single precision.
Wow.
Or as stored. Obviously, when
Yeah.
you do the computation, it's higher.
Yeah.
I had a question. So if you define the default, or you define the equals operator, and then you define the spaceship operator, but then in your code you call not equals, or you try to do a not equals comparison, will that run the code in the spaceship operator, or will that run the code in the equals operator?
The quality of.
Okay, interesting.
I haven't tried that. I haven't checked it in detail.
Yeah, I might try that.
Another edge case, Bob, you might be interested.
Sorry, I didn't. What would I be interested in?
Oh, another edge case.
Oh, another edge case. Oh, of course. Edge cases are fun as well as deadly. Fun and deadly at the same time.
And one will notice I'm lacking here, so that's where.
I'm retired. I don't have to worry about that. It's not my job's not on the line anymore. Used to be. But my reputation is.
That's why I'm retired too. A man of your stature, but yeah, when I come before an audience like this, like, yeah, I still like.
Folks, we got about 10 minutes. We want to be gracious to our host and let them go home on time. So anything else, or should we wrap it up?
For burgers.
Yeah, I'm not gonna be able to make burgers tonight. I got an early morning meeting tomorrow. Okay.
Thanks.
Yep. Thanks, folks. Catch you next month.
Thanks for presenting.
Yes, thank you.